Hello, this is Renshen from Google Research. Our paper is about post-OCR paragraph recognition by graph convolutional networks. OCR engines can find text in images. Traditionally, it outputs text lines and word. We want to go up the layout hierarchy to find paragraphs and maybe more. Those can be useful in downstream applications, but they are not always easy. Previous work have used rule-based approaches, segmentation models, and detection models. They have some limitations. Like for this example, we have 4 short paragraphs, densely packed and rotated. They are very hard for all of these approaches. So we propose a 2-step post-OCR process by graph convolutional networks, or GCN. So first, the OCR will work on the image. The text detector will find the lines, and the recognizer will find the words. And based on this output, the 2 GCN models will first split the lines across potential text columns and then cluster the lines into paragraphs. The GCN will need input graph. Traditionally, there are free line of sight or KNN graphs that can be overly dense sometimes, or axis-aligned graphs that can be too sparse. We use a beta skeleton graph, which adds an edge between 2 boxes when we can put a circle touching the 2 boxes without touching any other boxes. And that graph can achieve good balance between connectivity and sparsity. Using such a graph on the word bounding boxes, we have a GCN that can do node predictions on whether a word is a line start or line end. These predictions can be inferred from the word bounding boxes alignment propagated from the graph convolutions. And we can simply follow the model predictions to split the lines. And after that, we cluster these lines by another GCN. It takes the line bounding boxes and the graph and do predictions on the edges to see if the 2 lines should be clustered into the same paragraph. Again, the prediction can be inferred from the bounding box and the graph convolution propagations to take the signals from indentations or line spacing. To train these models, we need a large variety of layouts, and we get this by scraping Wikipedia pages or documents. In these web pages, the tag P indicates the paragraph that we use as ground truth. And we use randomized extension scripts to diversify the layout styles, like this double column, triple column text, and also variable line spacing and the text alignment types. And we further augment data by randomized rotations and perspective distortions. We measure the model performance by an F1 score with variable IOU threshold. And the reason is that there's always a mismatch between OCR lines and the ground truth lines. So multi-line paragraphs will generally have higher IOUs than single-line paragraphs, even though the multi-line ones are wrong. So a variable threshold can better capture the model performance. We run a group of models on PubLayNet set, and the F1 score indicates that GCN approaches are pretty good. While the scores on the PubLayNet may be very close, when we increase the difficulty of the dataset, like more variations on layout styles and further augmentations, the detection model degraded very quickly, while our GCN models can maintain a good performance. Also, the GCN models are better at generalizing from the synthetic data to real-world data, as verified by our multi-language evaluations. Here are some real-world examples with variations on camera angles, layout styles, and writing directions. Thank you for your time, and please refer to our paper for more details.